Hello and welcome to SudoKanard. Here is an arrow Sudoku puzzle which was featured on round 1 of Sudoku Grand Prix 2022. That was puzzle number 11. It was created by Japanese author Yosuke Imai, and I just explain what the rules are. I'm just looking for the number of points. It was 76 points worth, which is a big total, and it was quite tricky, mainly because of this huge arrow. So the rule, apart from the classic rules, is that whenever you have a circle or an oval with an arrow stemming from this oval, then the number here must be the sum of all digits along the arrow. So here it's a 2-digit number, and here it's just a single-digit number. So this has to be the sum of all those cells. And this is where we have to start, I think, because this is the sum of those 3 digits, which have a minimum of 1 plus 2 plus 3, that's 6. And those 2 digits, the minimum is 1 plus 2, that's 3. 6 plus 3 is 9. So this has a minimum of 9, and it also has a maximum of 9. So it has to be 9. And therefore, those 2 digits are 1 to 3. That's not a 1. And those are 1 and 2, and that's not a 1 either. So that's a 1. That's a 2. That's a 1. That's a 3. Those are not 3s. Sorry. And this is not a 2. There's already a 2 in the column. So that's a 1. That's a 2. So that's a lot of digits for a start. And something similar happens here. Here the minimum is 3, 1 plus 2. Here the minimum is 3, 1 plus 2. That's already 6 minimum. And this can't be a 1, so it has a minimum of 2. So that's a total minimum of 8. So this is 8 or 9. And there's only 1 degree of freedom. And I say that here we have a minimum of 1 plus 2. And because of this 3, we can't put anything but 1 and 2, because 1 and 4 would use 2 degrees of freedom, and we just have 1. So that's a 1 and a 2. And here we have 1 degree of freedom, so this is 1, 2, or 1, 3. This is not a 1, and we must have a 1. And this as well has a degree of freedom, so it has to be 2 or 3. So the options are either those are both 2s, in which case this is 8, or one of them is 2 and the other one is 3, and in that case this is a 9. So this is already an interesting deduction. And we see that this digit, which is 8 or 9, does not appear here, and in this box it has to be here. The other digits have to be selected among 6, 7, 8, and 9. This one is not the 9. And we see that the sum of these 3 digits is either 21 or 22. It's 21 if it's 6, 7, 8, and 22 if it's 6, 7, 9. And something of interest is that this digit now, as we have a 6, 7, 8, 9 quadruple here, we have 1, 4, and 5, this now has to be 2 or 3. And those 2 digits here have to be 4 and 5. So the interesting part is that we already have 21 at least. Those 2 digits here and there can't be 1 and 2, so they must be at least 3 and 4. So that's a total minimum of 28. This is at least 4. So that's a minimum of 22. Sorry, let's say 21, 28, 32. So that's already a minimum of 32. So this can't be a 2. It has to be a 3. And that's a 2. And this does not resolve the ambiguity that lingers here. It will be an 8 if this is a 2. It will be a 9 if this is a 3. And we see that this 6 must appear somewhere here. This is now 8 or 9, and this is 7, 8 or 9. We must have a 1 up there. This 3 now in this column 3 must go here. Oh, sorry. 3 must go here. This now can only be 7, 8 or 9. And we have, well, 4 options here, 1, 7, 8, 9. So maybe let's have a closer look. This one here is not a 7. Here the options are 4, 6, 3, and 8. 4, 3, 6, 8. And I won't pencil mark the 4 of them here. Let's just ponder the fact that we had a minimum of 32 with this digit and not counting this one. So this here can't be a 2. And actually this had a minimum of 4. And in this case, this has a minimum of 6. So we have already a minimum of 38. So this has to be 8 or 9. And we see that there again, we have at most 1 degree of freedom. And one other consequence is that this now is that in this box, 2 can only go into this cell. So that's a 2, and this is now 8. This is also 8, and we can remove 8 from those cells. So this sum is now 22, and our degree of freedom has been used. If, again, we think of the minimum of those cells, so that's 22, that's exactly 22. This has a minimum of 3, this has a minimum of 4. Those have a global minimum of 4 plus 6, which is 10, so that's 10 plus 22, 32 plus 4 plus 3, that's 39. So this has to be a 9, and the minimum is what has to be selected. So that's 4, 6, so this is not 6. That's a 6. That's 7 or 8. That's actually 7. It can't be 8. I get a 9 up there. This is not a 7. And up there, that's a 1, 7 pair. This 4 removes 4 from the options of this cell. This 3 is not here. It puts a 3 here. And this is now 6, 8 or 9. Those are 6, 7, 9, triple. This is not a 9. There has to be a 5 somewhere here. And those 3 cells are 6, 8, and 4. And obviously one of them is a 4. Let's move on. The 3s. We have here, put a 3 here. Those are not 7, there's 1 in the row, so this is 7, and this is a 5, 8 pair. This is now 9, that's an 8. And what has happened here? This is not a 4, this is 6 or 8. Now, in this box, we have lots of constraints. This can't be a 3, so this has to be a 3. That's a 4. That's not a 4. That's a 4. Here we must have 5, 6, and 9. This one is not a 9. This one is not a 5. And here, 1, 2, and 8. This can't be 1 or 2. And this is a 1, 2 pair. So we have lots of restrictions for the huge arrow. But some computations will have to be done. First, let's have a look at this 7th column. We still need to place 5, 6, 7, and 8. And that says absolutely nothing, so that's not useful. This row needs 4, 5, 7, and 9. So this is 4, 5, or 9. This is 7 or 9. This is 5 or 9. This is 4 or 5. And I could just have noticed that 7 could only go here. That is some restrictions, some restriction again. And this column needs a 3. It's not here, it's here. The other digits are 4, 5, and 6. This column still has a lot of digits to place. I just pencil mark the options here. 5, 6, 7, 8, because it will play a part in summing the huge arrow. So in this column, we still need 1, 2, 6, 8, 9. So I put 1, 2, 6, 8 here. This will never be a 1. The sum is much too big. It's not a 2. So this is 6, 8, or 9. Well, let's just ponder what the maximum value of this huge arrow could be. And it's going to be tedious. This is where I broke the puzzle during the contest. So let's just add the digits that are absolutely certain. So we have 2, 3. Those 5 and 4 are certain. That's 14, 17, 26. I skip this one. 26, that's 29, 33, 43. So that's at least 43. I should have, well, I just add some more room. And I just write 43. Oh, sorry, 43. So that's the amount we're sure of. And perhaps I use some color for the cells which are subject to some doubt. The ones that need some work. So what's the maximum value for those cells? Here it's an 8, here a 9, here a 6. That's 23. Plus 7, 30, plus 8, 38. So if I add a 38, then I get to 81. So this is not a 9. And this now is a 9. And this 9 is now certain. This is a certainty. So this now becomes 42. And 81 is still an option, except that 81 here had assumed that this was an 8. And 81, assuming this is an 8, would repeat the 8 here. So 81 is not an option. So the total sum must be less than 81. And 80 is not an option. We can't put a 0 here. So 8 is not possible as the 10th digit. So this has to be a 6. And this says that the sum of the remaining 4 digits, this one has no more uncertainty, so the sum of the remaining digits can't be more than 17. Now let's ponder the minimum. Here we have a minimum of 5, and here as well. So we already have 10 And if I make this a 7, we already have 17, and with this, we go past 69. So this can't be a 7, it has to be a 1. So now this is 53. Here we have a minimum of 10. Could it be an 8? Could this one be an 8? Probably not. With an 8, we get to 18, which makes 71. That's too big a choice. So this is not an... actually this 6 makes this an 8, sorry. And this is not a 6. Alright, so now 53 plus 10 plus 1, that's 11. Oh, yes, 11. So this is a minimum of 4, and I could have guessed as much looking at this. Let's just point out the fact that in this column, this can't be 1 or 2, so this has to be 1 or 2. This can't be a 6, because there's a 6 in the box, so this has to be a 9. This now has to be a 6, this has to be a 5. And in this column, 6 can only go here. Also, this digit is an 8. We can remove 8 from that. Right, so this 6 now must be added to the total. That's... what has happened? That's 59. And we know that this plus that added to this makes 68. So this plus that must be 9. So we put a 2 here. That's a 1. That's a 1 and a 2. And this is a 7. And now all arrows are fulfilled, and the rest should be standard Sudoku. Alright, so what happens? Here we need 8 and 6. There's a 6 in this column, so this is 8. This is 6. I get a 5 here. This 6 makes this a 7. This is a 9. That's a 6. That's a 7. That has to be a 9. There's a 6 here, so this is 4. That is 6. This now can't be a 9. We still need 4, 5, and 9 here. There's a 9 in this column and a 4, so this is a 5. That's 4, 5, 4, 5. That's a 4. That's an 8. That's a 5. Here is a 9. And we'll finish with an 8. And so I don't get the fireworks. I think it's because of those digits. Probably, and because of the coloring. So let's remove the coloring, and well, I don't get the fireworks. This is ominous. I just have a look at the solution booklet on my other screen, obviously. And I just checked that I didn't make a mistake, as I'm very prone to. I'm not sure prone to is the correct way of saying that. As you may have guessed, English is not my first language, so let's have a look. Well, the first row is correct. And what I'm seeing seems to be correct. Well, I don't know why the answer check didn't trigger, but I think that doesn't matter. This was a way to solve this very well constructed puzzle by Yosuke Imai. And thanks for watching this video, and see you soon on SudoKanard.